shall we start? Okay. I know everyone is hungry, but I will try to keep this conversation engaging because, yeah, we are here to talk about incidents and we want to predict incidents, which means like overall for now we have seen incidents when they are happen, AI agents come over, take what is happening and then try to fix the problem. Or there are different AI agents which work during the development cycle to make sure that those incidents don't happen. But what if there will be incidents? We cannot get rid of those incidents. What if we get rid of, or if we get enough of the lead time to act upon those incidents so that we can make reduce the probability of making them happen. So I will be talking about that. And before I start, who am I? I'm engineering manager at Payment Tools. It's a Railway Group company. We process payments, and I worked in many industries like gaming, entertainment, and everything. So you can also follow me on me. I write a lot of things, dump all of my ideas on Medium, so you can also feel free to follow them. And the problem, this is what we talked about. Like reactive pages, we do get reactive pages. What that means, like when the damage has already been done. And when that damage has already been done, then we are acting upon them to fix that. And that is a reactive behavior. And for example, for if we give the insight for us, we get around 350 alerts per month. So to say, that translates into 30 incidents. And our incidents are very critical because they have real money involved. We process payments, billion of euros each year. So whenever there is an incident, there is serious money involved. So incidents are critical for us. And we want to reduce the amount of incidents as much as possible. But we cannot avoid them. That is the reality as well. So what is the idea? Like we want to shift left. What that means? It means that we want to get enough lead time to act on the situation when something going south, and we try to fix those and avoid the possibility of having an incident. Most of the time, it can be a simple command or simple act, but in sometimes it can be very critical. Which for example, 1 week back, US East 1 AWS was down. So those are the incidents we cannot avoid. But for example, your application is running out of memory, that we can avoid before that translates into the incident. So what is the whole philosophy? As an SRE, we do, or in any engineering team, we do get a lot of signals. And from those signals, we will convert those signals into the features, and those features will be fed to model with some guardrails. We talked about AI safety. How do we work around those things? So those guardrails are there to make sure that we are controlling the behavior of our model in a limited scope. And when we have some model, we also need to have evaluation. How is it performing against certain actions? Did it good, or did it something can be improved? So those evaluations are there to make sure that our models are behaving correctly, and we wrap everything under safety because safety is very important as well. Talking about signals, we talk about signals, we get metrics like log, traces, like latency, errors, saturations, and logs as well, traces, critical path, what are different span. And also, if we heard about DORA metrics, so deployment frequency, change trace, and SLO burn rate as well. So those are all the signals that we can get. Now, the idea is we get all of these information, we get all of these metrics. How do we try to convert them into the features that actually matters to us? So let's talk about features. So this small chart we will see everywhere. It's a brain map. Where are we? So we don't get lost. And if we talk about feature, it can be, for example, windowed stack. So latency is just a latency. What does that mean? So if we translate into P99, like 99% of our metrics or requests having some, we do have exponential. When we have a lot of spikes in the data, we want to smoothen it to make it more readable, make it more effective. and gradients. So all of those things could be our, like, we put it into the windowed stack, like, which means like what is our P99 in 1 week or in 1 hour or in 1 day or in 1 month. And those would be our one of the feature. Change risk. We talked about Duravet. So change risk like what is our churn, what is our size of the changes that gets deployed, who does deploy more changes, and also dependency graph. When there is an incident or when there is some problem with the services or microservices, we struggle a lot. Okay, what is the downstream service? What is the upstream service? From where the outages are happening, or how the different services are connected to whom? So if we talk about like more than 200, 300 microservices, it gets more complicated. So building a dependency graph is becomes crucial in that case. And then we translated our signals to feature. Now we talk about models. Models here, they are not actually, I'm not going to talk about LLMs. They are all very smart, very intelligent, but models here, I'm talking about traditional models, which actually works. And we can leverage LLMs to use those models. What actually used to work? Like anomaly detection based on time series data. This is one of the models. We can leverage LLMs for this. Logistic regression or gradient trees for our change risk. So we get to know, okay, what is, we use our LLMs for this model. What is our lines of code which are being changed? What are the tests? How many tests are being added? How many alerts are related to those services happened in the past? So based on all of those things, we build logistic regression and log embedding. This is very new. So for example, we talk about vector database these days, and log embeddings are here for novelty and drift, which means, for example, if our services are emitting logs and we get, okay, query executed, request accepted, and we create embeddings for all of those. But what if something new comes in? TLS handshake fail. So those kind of errors is something new, which model didn't know. So for that, we need to build those embeddings so that our model can understand, okay, this is something new. I have never faced this before. What do I need to do? And the idea is we use these basic techniques to, we do not need to build our own deep neural net. We do not need to build our like very sophisticated AI in-house to do all of those things. We integrate our existing observability stack like LGTM stack, Datadog, or anything, and we integrate with those models and start moving forward. What that means now, let's come with a guardrail. Like when there is an incident, we act upon that, but we also need to make sure that we are within our SLAs, we are following SLA burn rates, what is, and blast radius. So when the LLMs or when these models execute certain commands, we need to be making sure that they do not execute something like, for example, delete the entire database. So we need to have those guardrails, like you are allowed to do certain things in certain namespace on certain service. And what is a time box, like timeout, like you need to wait for at least 15 minutes to perform the next section or something like that. So those can be the guardrails. And for critical things, we need to build some approvals or acknowledgement on those actions that are being made by these models. If, for example, if the model decided to do something and it is going to actually impact your customer data, you need someone to acknowledge it, or someone to, okay, you say, I approve this. So this could be one of the things. And the last thing would be like, yeah, I have already talked about time box, but also kill switch. So if something goes wrong, a kill switch, kill everything and restore the entire systems to Stone Age with no AI magic, so to say. And now we have built signals, features, we talked about models, guardrails, and how do we evaluate that we are behaving perfectly. Precision and recall, these are very important metrics when we calculate about incident. Precision means like how many incidents did we get, like having less false positive is means high precision, which is very good. Recall is something like whatever we get and versus how many incidents did we miss. So fewer incidents that we miss means better recall. And F1 is a mathematical formula for precision and recall and and in the end we want to achieve high precision and high recall, which is very good for our systems. What is one thing which we could talk about is false positive per week per service. This could be one of the factor for evaluation. So how do we evaluate our model is performing good? So how like it is again related to precision as well and everything tied to that. Cost of action and inaction. So we define earlier within from one talk we heard about translating SLOs into business metrics or business terms. And this is like what how much money do we lose? And it is something related to that. What would be our cost of action and what would be our cost in action if we don't do anything or if we don't act upon those. And there is always automation in place. And we have when we build automation, we also have to trust automation and also evaluate how much human review are we getting. So there was one incident in the past when Slack went down, their system started to scale themselves, and with that auto scaling, their automation started to scale things, and their systems couldn't handle, and then it went into the loop. So it means that we need to trust automation, but we also need to have human reviews at some place, and we need to find a balance between those things. If we talked about signals, we talked about features, we talked about models, guardrails, and their evaluation. I'm not going to do deep like the live demo because I have seen that they don't go well in most of the cases. So I have taken screenshots of the things which I am going to share with you. Trust me that it's there. So the screenshots are real. But before we go into more into those things, we talk about architecture. So we do have Prometheus or our LGTM stack, and our services pushes our metrics to Prometheus. We have the predictor, which uses these models or leverage those models, and it pulls data from the Prometheus. What it does, it verifies against those guardrail checks whether I'm in my guardrails, I'm following the rules. If it's before AI agent. So here's the AI agent. Sorry, I skipped that part. So when it gets all of those metrics sent to the agent, comes back with the response, and with the response it checks whether those actions that AI gave me, that agent gave me, is under the guardrails. I'm not breaking any rules here, and if that's the case, it applies those actions, and then the cycle goes on. What predictor looks for actually? It looks for window distance, which we talked about earlier, P95 metric, error rate. So generally, most of the time, teams have built like alert me when the error rate is exceeding 5% of like in last 1 hour, and then page. So we create error rate, mean and standard deviation as well, z-score to detect anomalies and outliers, and threshold values. So what would be the z-score threshold value for us, and also the error rate threshold? Z-score is something which is you have a time series database, anything which is outlier, deviating, and then it becomes an anomaly. So z-score is help us to identify those anomalies. In the industry wide, z-score of 3 is a very standard practice of having it, but we can tweak it depending on our use case or as we see fit our system. And when predictor gets all of those information from Prometheus, what it does, it sends the context to our AI, and context is very important. What does it send? Is current snapshot of signals, Z threshold value, error rate threshold, recent history of a snapshot. So whenever it takes a snapshot, it also contains the history of it. And based on the model's context window, the history can be adjusted. So for example, last 10 or last 50 snapshot. And if we are talking about in Kubernetes term, deployments and namespaces, what those actions will be taken. And in most of the cases, restart solves the problem. Or we need to start small. take a baby step. And predictor does four things. First, it observes. Based on the observing, the patterns that it gets, it either decides to scale up or scale down. It either it decides to restart or it decides to do nothing. That doing nothing is also, and the idea is there can be many, but 90% overall I have seen the restart or scaling solves the problem. But that's where we start. And we, based on the behavior, based on the patterns that we see, we can always add more action. So for example, you see there is a simple snapshot version, P95, error rate, mean and standard deviation. And here we see a snapshot which is being created. And when the snapshot is being created, it sends to the agent. And agent says everything looks normal to me. I have threshold value, I have present value, and it looks normal. So my action is doing nothing. And for example, now when the errors are detected, right? So the snapshot is being updated now. And when it's updated, AI make a decision. Okay. It says, I need to restart. I see there are some errors, and now I need to start it, restart, and then it checks the guardrail, and guardrail passes. Okay, you are allowed to do restart, and then we see executing a restart here. And when it performs the restart, it observes. It waits for some time, and when you can start seeing the error rate started to go down, and based on the error rate, it says recovery detected within the time box. What did we achieve here? We achieved here is an incident which is about to happen or which was supposed to be happening at 10 minutes late. With a higher rate, your services are going down, and a simple restart fixed that problem. So we get enough lead time to prevent that errors translating that into an incident. And now we talked about this. Safety is very important. What that means, here we have heard a lot about AI safety earlier in the earlier talks. Policy as a code is very important. Staged rollout and shadow mode. What that means, like when we are trying to roll out those predictors, we do not roll out for everything. We roll out for one service at a time. We shadow it first. Like, for example, we start with just observe action and none action. We don't do anything. And we observe that, and when we have enough trust, we add more action in the AI. We do have deterministic runbook and idempotent. What that means is like anyone saw those runbooks, like if there are error, contact this team on Slack channel, and those kind of runbooks are not the runbooks. They are just a escalation path. Runbooks are when do you see this error, particularly execute these actions. And when those actions are executed, then move forward. And if we execute that runbook n number of times, there shouldn't be any change into the system. It shouldn't crash. And we have clear ownerships and escalation path. When there are a problem, when there is an incident, there are many number of times that a team X says, it's not me, it's another team Y says it's team Z, and there is no clear ownership. When we have a clear ownership and a clear escalation path, this becomes more effective and more safe. And after that, ethics and risk. Also, when we talk about AI, anywhere, ethics always comes into the picture, and the risk as well. How we can overcome with these things is like explainability, as we saw in the previous slides. When AI takes an action, it presents its decision with a rationale. So we maintain all of those actions and the rationale behind it. We do create privacy and retention limits. How many actions or we have enough retention limits for the action which were performed by AI. We have fail-safe defaults, and also we override manually. So kill switch as well. That being said, what did we get in the end? We get high precision, high recall. We get a desired lead time where we acted on an errors or a problem in the system which avoided the incident. We get less false positive per week per service. We get less human view rate, which means like humans are looking less, okay, what happened, I need to restart, and those things where they can just simply start using their time into something more meaningful, and we get more automation. And how do we adopt all of those things? Is we can start with just pick one service. We don't need to just do for everything. We start with one service. We pick two use cases in that service. That could be our customer user journeys. We pick normal customer user journeys. We start with those. We roll out this in a shadow mode with weekly reviews. So teams sit together, see what has happened. Is it correct or it is not? And we automate it with the safe runbook with approvals. And once it is like working fine, after a month, we start with, okay, let's start with one more service or add more use cases into that. So we expand this automation framework and we can prevent incidents much before they are. And that's pretty much it. I am